Hey y'all, final exam coming up, and so I'm gonna go do some of the review problems with you. It's gonna go pretty fast, so pause if needed, or if you already know how to do the problem, then fast forward to get to the next problem. I'm gonna do all the problems that are circled in orange. So let's begin. Segment addition postulate states that this segment plus this segment is equal to the total of that segment. So that's what we're gonna do. We're gonna write an equation that makes them equal. So I have x plus 5 plus 3 is equal to 3x minus 6. And some of these I'm gonna solve, some of these I'm not. I am gonna solve this one, bring the x's to the same side. So subtract 3x. I guess I could have brought it to the other side. Now I'll have to do negatives. Okay, combine like terms, that's 8 equals negative 6. Now bring the 8 to the other side. Negative 2x is equal to negative 14. Divide by negative 2. That is 1x, positive 1x, is equal to 7. And all they asked us to do was solve for x. When the lines are parallel, they have to be parallel. Okay, when the lines are parallel, then that means there are several important relationships. These right here are inside of the parallel lines, and they're on the same side of the transversal. So here and here. Those are called same side interior. When the lines are parallel, same side interior angles are supplementary. So that's what we're gonna do, is add them and equal them to 180. 13x minus 7 plus 8x minus 2 equals 180. Combine like terms, so that would be 21x, negative 7 minus 2, negative 9. Add 9, 21x is equal to 189. And we have our trusty calculator. 189 divided by 21 is 9. And we've solved for x. For number 4, find the exact distance between the given points. I'm going to create a slope triangle. 1, 2, 3, 4, 5 is the base. 7 is the height, then I'm going to use Pythagorean Theorem to find the distance. Remember the hypotenuse, that slant, across from the right angle does not touch the right angle. That is always C. We're going to square root both sides. And we need to find the exact answer for number 4. So let's see if there are any perfect squares that go into 74. Okay, you can test anything that's under 74. So we could do 74 divided by 64. That's not gonna work, it's too big. And then just keep going down perfect squares from there. So under 64, if that's 8 squared, then we go to 49, which is 7 squared. 49, yeah, not gonna go into this at all. Before 49 is 36. That would be the closest, but it doesn't quite go into it. 25 doesn't go in. We could try 16. Also doesn't work. Divided by, next is 9. We're just going down the perfect squares list. Divided by 4. So that's it. Our answer is square root 74 is the distance between these 2 points. Number 6. All right, there's a lot of stuff going on in here. If it were labeled on the actual diagram, I can almost promise it would be so much easier, but it's not. So we've got to do some labeling. Make sure you're very careful with your labeling. So Hij is 87x. H-I-J. Okay, so I'm going to assume that involves these two angles because those are the other angles we're talking about. So this whole thing is 87x. Now, HIP is 24 degrees. And PIJ is 76x minus 2. Now, just like we did up here, where the small plus the medium is equal to the long, the total, that's what we have to do here. So 24 plus 76x minus 2 is equal to 87x. Bring the x's to the same side. And then I'll combine my like terms. So 22 is equal to 9x. Sorry, that should be 11x. So that should be 11x. Can't find my whiteout. Divide both sides by 11. X equals 2. Are we done? No, we are not. Find the measure of Pij. So Pij was the 76x minus 2. (76 times x), you already know, that's actually 2. Okay. (150). And that is the measure of Pij. Moving on, find the measure of angle B. All right, these two make a straight angle. They are supplementary. They add up to 180. B plus 123 is equal to 180. And then you solve. All right, B and 53. So if this is 90, then this is also 90. So 53 and B are complementary. Or you could say B plus 53 plus 90 is 180. Either way, you're going to get the answer. So B plus 53 is equal to 90, and then solve for B. First, identify the relationship. So find the measure of the angle indicated in bold. Identify the relationship. They are outside the parallel lines, so they are exterior. And they are on opposite sides of the transversal, so they are alternate exterior angles. When the lines are parallel, alternate exterior angles are congruent. Make them equal to each other and solve for x. So 12x plus 9. Bring the x's to one side, the numbers to the other, and then you'll get your answer. All right, what is this relationship? They are in the same exact orientation. One is inside, one is outside. They're on the same side of the parallel lines, but they're not same side interior because one is inside, one is outside. Those are called corresponding angles. Corresponding angles are congruent when the lines are parallel. So make them equal to each other and solve for x. So 14x minus 4 is equal to 13x plus 2. Moving on. All the angles in a triangle add up to 180. So I'm going to add these all up. 10x plus 20 plus, do not forget that this is 90 degrees, even though it's just a box and there's no number written. You know what that box means. That means it's a 90-degree angle, so make sure to add that in, is equal to 180. Combine like terms, so 10x plus 110 is equal to 180. Watch my mental math. Subtract 110 on both sides. 10x is equal to 70. X equals 7. Okay, number 13. We are going to first graph this quadrilateral and then rotate it 90 degrees clockwise about the origin. So C is at -2, 1. D is at negative 1, 3. E is at 3, 1. F is at 1, negative 1. And so we will connect to make this quadrilateral. Let's get some tracing paper, put that on there. Not only do you want to put the shape on the tracing paper, but you also want to make sure that you line up that origin. So go ahead and put a plus sign to where the origin is, so that once the plus sign lines up again, we know we've gone 90 degrees, because at the plus sign there are 4 90-degree angles, perfectly perpendicular. So 90 degrees clockwise. So we're going to turn, and here is my new shape, and now we just need to graph it. It's okay if it overlaps. So the new C is here, C prime. Where's my plus sign? There we go. The new D is at where E was. F prime is here. And then we have E prime is here. All right, and that is correct. Moving on, dilation of 1.5 about the origin. Okay, so dilations for me are much easier if I know what the actual numbers are of the points, so that's what I'm gonna do first. So I should have T is at negative 1, 3. Okay, and then we have U is at 2, 2. And then we have V is at 0, negative 2. And then S, negative 1, 1. When we get our new numbers, dilation of 1.5, so we should times every single thing by 1.5. Okay, so T prime is going to be, well, that one's easy. Negative 1.5, 3 times 1.5 is 4.5. U prime is 1.5 of 2, so that's 3. V prime is 0, negative 3. S prime is negative 1.5, comma 1.5. And then we'll graph these points. So negative 1.5 is right here, plus 4.5, so 3, 4.5. So this is T prime, U prime, 0, negative 3, V prime, and negative 1.5, up 1.5, S prime. All right, and there's our dilation. State if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. Okay, remember that these vertical angles are always congruent. However, there are no other congruent parts, no other congruent sides, no other congruent proportional sides. These are similar triangles, or we're trying to see if they're similar. So there are no other sides to show if they're proportional, and there are no other angles to show if those are congruent. So not similar. Moving on, these are definitely congruent, the angles, because they're vertical angles. And so we have, okay, so we have two angles that are congruent. Good. We have different sides going on. It looks like this side might go with this one. And you can tell by looking at the numbers. Okay, so 36 is bigger than 18. So we're going to do 36 over the bigger side on the other triangle. So 36 over 24 is 1.5. And then we're also going to do 18, starting with the same triangle before that we did this one. 18 over 12. Also 1.5. And then the angle that is between, that is sandwiched by these sides, that angle is automatically congruent because they're vertical angles. And all vertical angles always are congruent. So we have side, angle, side. The angle is in between. So TUV. TUV. They went from the unmarked side to the medium, to the shorter side, sorry. So that's what we're going to do. The unmarked side, which is CB, to the medium side. So CBT. And how do you know that? Side, angle, side, similarity. All right, so now we're going to find out what is this missing piece. It's a question mark, but we'll call it X. Find the missing length. The triangles in each pair are similar. Good, because if they weren't similar, we'd have no way of knowing how to find X. Okay, so sometimes it helps to draw these as two separate triangles. If you can see it without doing that, great. But if you can't, no problem. That's what we're going to do. So this long side, JK is 45. JL is 60. And then I have the smaller version. Make sure you line up those letters. That can help. JC is what we're trying to find. JD is 24. And do not forget that J and J, those are the same angle. But that would only be helpful if we were trying to see if these triangles were similar. We already know these triangles are similar. So we can set up a proportion. I like to do big over small. So I'm going to do 60 over 24 is equal to 45 over X. When these triangles are drawn in this way, then we can easily see by their orientation which sides are corresponding. Cross multiply. So 60 times X is 60X equals, sometimes people forget to put the equals between, they don't remember what happens next, 24 times 45. 60X is equal to, okay, 1080. 60 over 60 is 1. And that would be 18. Good. Let's go back to number 19 actually, because some of us forgot that this similarity statement gives us so much information. So helpful. Okay, side NM, so this side goes with NE. Side ML goes with EF, and side LN goes with FN. Okay, this one's a little more obvious. This is 117, this is 117, this is 65. This one has to be, again, you guessed it, 65, because it looks like these are just the same, so these would also need to be the same if the triangles are similar, which we know they are. But reading a similarity statement, that can really help to tell you which sides correspond with which. How are you going to set up your proportion? You need to know that. Determine if the two triangles are congruent. All right, if they are, state how you know. On your note card, put all of the proofs of similarity, and then separately put the proofs of congruence so you know what those are. Or you could just check the multiple choice and, you know, rule out the ones you think it's not. Either way. Vertical angles are always congruent. So if this is a right angle, this one's also a right angle. And I'm going to color it in just to emphasize that. And it looks like this side is congruent to this side. And it looks like this side is congruent to this side. So we've got side, side, angle. Wait a minute. Angle, side, side, ASS. That does not exist. But it's a right angle. And a right angle is very special, has very special qualities. So which parts of the right triangle did they give us? They gave us here is a leg, and here it does not touch the hypotenuse, so it does not touch the right angle, so it has to be the hypotenuse. So they gave us hypotenuse, leg, congruency. All right, are these congruent? Who knows? We have, this is a shared leg, again, another right triangle. And then this one is congruent to that one. Leg, leg. Congruency. All right, find the missing side of each triangle. Leave your answers in simplest radical form. Do not put it in your calculator and round it if they're asking for simplest radical form. They want it exact, okay? So here, we're going to use Pythagorean Theorem. We're given two sides, we're trying to find the other. One of the legs is A, one is B. It doesn't matter which, but it's very important that C is the hypotenuse. The Pythagorean theorem is A squared plus B squared equals C squared. Square root of 257 squared is simply 257 because square root and squaring are inverse operations. Get that x by itself. Then we square root both sides. And we have x is equal to square root 136. Is there a